Section 1.4 covers solving absolute value equations. So we've graphed them, we've transformed them, and now we're going to learn how to solve these absolute value equations. There are properties of absolute values that we need to know about before we can get started. The four properties of absolute value are as follows. We have that the absolute value of A is always greater than or equal to 0, which makes sense because we know that distance is always positive and that absolute value measures the distance from 0 on a number line. Therefore, it should always be positive. The second property of absolute value is that absolute value of negative A has to be equal to the absolute value of A. The distance from negative A to 0 and A to 0 is the same, so their absolute values are the same. The third property is a multiplication property. So if I am multiplying absolute value of A times the absolute value of B, I can simplify that down to the absolute value of A times B. Follows suit then that the absolute value of A divided by B can be separated to the absolute value of A divided by the absolute value of B. Those are the four basic properties of absolute values, and we'll be using these ideas during our notes. Okay, how to solve them. How to solve absolute value equations. An absolute value equation will be given to you in the form absolute value of ax plus b equal to some value c. So there are two options for the type of equation we'll have for how to solve it. When that value c, so what it's equal to, is greater than or equal to 0, and when c is less than 0. So when c is greater than or equal to 0, we're going to follow three simple steps, and you're going to remember these steps pretty easily. The first step is to isolate the absolute value bars. Once you have the absolute value bars isolated, which means it's the only thing on its side of the equal sign, you will separate the two equations. So you'll have ax plus b equals c, so the equation without the absolute value bars, and ax plus b equals to negative c without the absolute value bars. The last step is to solve each equation. So you'll take the bigger equation with absolute value bars and then isolate, separate, and solve. Isolate, separate, and solve. It'll be pretty simple. When c is less than 0, so that means if this number right here is negative, we're going to have no solution. Why do you think that's a thing? Why do you think we'll have no solution when c is less than 0? Remember that absolute value has to be greater than or equal to 0. So if this number c is less than 0, we will have no solution. It can't be a negative number. Let's try a few problems before we move on. So the instructions will ask you to solve and graph. We have absolute value of x minus 4 equal to 6. We want to isolate the absolute value. Okay, well, right away, this is already done with the I step. Right now, the absolute value bars are the only thing on its side. There's nothing added or subtracted or multiplied to the absolute value bars. So we've isolated. We separate. So we take it out of the absolute value bars and set it equal to the regular number c, and write the equation set equal to negative c. So we have x minus 4 equals 6 and x minus 4 equal negative 6. All we have to do now is solve each equation. We use inverse operations. The inverse of subtracting 4 would be adding 4. So we have x equal to 10 and x equal to negative 6 plus 4 is negative 2. I have solved. There's my isolate, separate, and solve. To graph these, since they are just two solutions, I'll have negative 2 and 10. And since x is right there, it is equal to those. We've put a closed dot since it's equal to it. Here's one for you to try. Absolute value of x minus 1 equal to 4. Solve and graph. Our isolate step, again, is taken care of. Okay, we're not going to need to solve for anything. It's already isolated, so we separate. X minus 1 equals 4. X minus 1 equals negative 4. Then I simply solve using inverse operations. X would be equal to 5, and x would be equal to negative 3. There's my solve step. To graph on a number line, I just plot the 2 points. How'd you do? Alright, our third example is a bit different. We have absolute value of 3x plus 1 equal to negative 5. I go to the isolate step. I have already, again, isolated my absolute value. We'll have an example here in a minute where it's not. But do we notice something here? What is the value of c? That is a negative number, which means my value c is less than 0. That can't happen. So we say that this has no solution. Example 4 does require us to isolate, to do a step to do the isolation. Okay, do you see how the negative 2 is multiplied in the front of the absolute value bars? So right now, absolute value is not isolated. I need to undo multiplying by negative 2 so that the absolute value bars are isolated. Since they're smushed next to each other, they're multiplied. To get rid of multiplication, I divide. I would have x plus 5 equal to negative 10. Now it is isolated. What do you notice about this absolute value? Again, we have the same problem where c is less than 0. That can't happen. So we have no solution. We have just a few more examples here. Number 5. Okay, we have the equation negative 3 absolute value of 1 minus 2/3 v set equal to negative 9. Right now you might be saying, oh, c is less than 0. We cannot determine if it has a solution or not until the absolute value bars are isolated. So we do need to do our step here to isolate. To get rid of the negative 3 that is multiplied in front of the absolute value bar, I will divide it away. Negative 9 divided by negative 3 is a positive 3. So is this okay? Will this have a solution? It will. So now we've gotten to a point where we need to separate. 1 minus 2/3 v equal to 3, and 1 minus 2/3 v equal to what? Negative 3. I just solved each equation. I want to isolate the v, so I subtract 1 on both sides from both equations. that will cancel out. That's the inverse operation. So I have negative 2/3 v equal to 2 and negative 2/3 v equal to negative 4. You can multiply by the reciprocal to get rid of that fraction, or take it piece by piece. Okay, the opposite of division, like in the bottom of this fraction, is to multiply. So I'm going to multiply each side by negative 3. Okay, that cancels out the denominator, and I'm left with 2v equal to 2 times negative 3 is negative 6, and 2v equal to negative 4 times negative 3 is positive 12. Simply solving, we're almost there, team. We have v equal to negative 3 and v equal to 6. We have solved. All we have to do is graph. Like I said, all you do is draw me a number line and plot the 2 points. Example 6 is for you to try. Isolate, separate, and solve, then graph the following equation. Absolute value of 3x plus 9 minus 10 equal to negative 4. We start by isolating the absolute value bars. There's a minus 10 at the end. The inverse of minus 10 is to add 10 to both sides. I will have absolute value of 3x plus 9 equal to 6. It has been isolated. Now I separate. 3x plus 9 equal to 6. 3x plus 9 equal to negative 6. Inverse of adding 9 is subtracting 9. I'll have 3x equal to negative 3 in the first equation, and 3x equal to negative 15 in the second. Divide by 3 to get the x by itself. I'll have x equal negative 1 and x equal negative 5. All that's left is for me to graph. Negative 5, negative 1, and draw my dots. How'd you do? If you made any mistakes, tell me about them. Our next section is about writing absolute value equations. The formula, where you will plug things in, looks like the following. You have the absolute value of x minus your halfway point, the point in the middle, kind of like your midpoint. X minus halfway point set equal to the distance to that halfway point. And what we mean by that is if you have a graph and your two solutions, look familiar? You have a graph with your two solutions. In the middle of them, whatever number is your halfway point. And your distance will be how many steps it takes you to go from your solutions to that halfway point. The distances should be the same on this side as is on this side. Now it's important to notice that when you're using this halfway point, you're going to be plugging in the opposite sign than what you see here. So if your halfway point is at 3, your equation is going to say minus 3. And if your halfway point is at negative 5, then this should say plus 5. You're using the opposite value, the opposite sign. So you are told to find the solutions without solving, and you're given the following equation. X minus 4 equal to 2. It wants you to find the solutions. We can do that because we know how to graph this. If this is my halfway point, I have 4. This is my distance away until I get to my solution. So from 4, I'm going to go 1, 2 spots away, 4, 5, 6. Okay, like this is a distance of 2. Then I'm going to go distance of 2 this way. This is 3, 2. So my two solutions here are 2 and 6, based on the drawing. We're going to have to write our own absolute value problems when we're given a word problem. So here we go. In a cheerleading competition, usually the minimum length of a routine is 4 minutes. The maximum length is 5 minutes. The question then asks you to write an absolute value equation to represent the situation. Okay, wants you to write an absolute value equation to represent this. If they told us the maximum and the minimum, they've told me my solution. So if I were graphing this on a number line, we'd say that it can go from 4 minutes to 5 minutes. Okay, those are my solutions. What's the halfway point between 4 and 5? 4.5 is my halfway point. So what's the distance between my halfway point and my solutions? We only have to travel a half of a step, 0.5, to go from my halfway point to that maximum and minimum length. See how it's the same on both sides? So that means that my equation here is 1 minus the halfway point set equal to what? The distance from the halfway point, which is 0.5. We have shown this cheerleading routine's absolute value equation.